Okay, somebody remember to turn that off. I forgot the other day. On and on and on. All right. Okay, so before we can do some of the permutation combinations in this thing, we need to talk about the factorial symbol. Factorial symbol, it looks like an exclamation point. It's defined this way, n is greater than or equal to 0, but really for 1 and 0 factorial, it's just kind of like, well, this is what it is, okay? So 0 factorial is 1, 1 factorial is 1, okay? Now, neither of those make any sense if you know what a factorial means, okay? The factorial means we're going to take this number, like n factorial, we're going to take it times itself, then we're going to take it times 1 less than itself, times 2 less than itself, times 3 less than itself, etc., until we get to 1. Okay? So, for example, let's talk about 2 factorial. 2 factorial would be 2 times 1, which is 2. Well, you'll see. So it gets to 1. Okay. 3 factorial is 3 times 2 times 1. See, it gets to 1 eventually. What is 3 times 2 times 1? 6. So 3 factorial, 6. Okay? 4 factorial. 4 times 3 times 2. We're at 1. We're done. That's what I mean by getting to 1. All right. 12 times 2 is 24. 5 factorial. 5, 4, 3, 2, 1. What is that? 120. Okay. Be 24 times 5, right? Because, you know, you got the 5 here that you didn't have here. And then 6 factorial was 6 times 5 times 4 times 3 times 2 times 1, which is 120 times 6, what's that? 720. Okay. Now, the factorial key is nice, but it's really, like, I don't know how helpful. It's kind of buried in there, but let's talk about 7 factorial divided by 5 factorial. You're going to take 7, 6, 5, 4, 3, 2, 1 at the top. And then you're going to take 5, 4, 3, 2, 1 at the bottom. 5, 4, 3, 2, 1 is going to cancel each other. So what's 7 factorial over 5 factorial? 7 times 6, which is 42. Okay, let's dig it out on our calculator. It's in the probability section, which is in the math menu. Everything's always in the math menu, it seems like. All right, so, I was messing with this yesterday and I can't get rid of it. Anybody have a suggestion? Just, I don't know. Hopefully it'll go away. Yeah, there we go. Okay, so math. Here we go. That's not, I did second, I guess. Yeah. Math. Okay. Now, all the way over for you is probability. Okay? So, to get all the way over is, this is the math menu. Okay? Then we go right, not to number. That's where you find the absolute value. You've used that before. Not to complex, but to probability. See the factorial? All right. There's the probability, and there's the factorial. Okay? Now, I should have thought ahead because I want to do 7 factorial. So, let me clear. 7, math, right. Probability number 4 is factorial. Okay, while I'm at it, I'm going to divide by 5, math, right. Probability 4, factorial is 42. Okay, so you can do it that way. Certainly is a lot of trouble to find it all, but it is there. if you want it. Okay, so we go to math. Oops, these are math menu, probability menu, and then whatever you need is factorial after that. These are backwards. I'm trying to arrange for people that aren't here. Probability and factorial. Okay. All right. So there you go. Be careful about the factorial. If it gets too big, the calculator say overflow. Okay. So for example, let's say we want to do a fraction down the road. We want to do 10 factorial. All right. So I got to go to probability number 4. Okay. Times 8 factorial. Okay. So I got 10 factorial times 8 factorial over 2 factorial. Let's see what happens. Sometimes, oh my, did rand instead of rand. That's a random number. Number 4, not Randy Lupner. All right. Now, that's not an overflow, but it is a little weird. 10 factorial times 8 factorial over 2 factorial. Okay. Remember what that says. What does that really say? 7.3156668 times 10 to the 10th, which is a huge number. Okay? But eventually they're going to get, if it gets too big, they're going to put it in scientific notation for you. Okay? And that's totally fine. Still. Okay? So anyway, that's where you find the factorial. Let's talk about permutations and combinations. Okay. We've already been talking about permutations. We just haven't named them. But it is an ordered arrangement of a certain amount of objects, or objects, chosen from n objects. So for example, if I want to take my 5 people here, and I want to choose 3 out of them, how many different orders, how many different groups could I make from the 5? So that would be 3 taken from 5, okay? There are 3 basic types of permutations, all right? The n objects are distinct, different, and repetition is allowed in the selection of r of them, okay? So, distinct with repetition. So we'll be going back over these, but we kind of had some of those already. Yep. Okay. Let's talk about let's say we have a code. Okay. We have a 3 number code. Okay. Let's talk about what kind of things have a code. A lock. Okay, there's 3 numbers on there. How many different combinations of locks could we have? Okay, well, how many numbers are there? There's 10 choices for the second one. Okay. Once we use that 3, can we use it again on the second code number? Yes, of course we can. So there's a 10 and there's a 10. So that's the permutation with distinct and allowing the numbers to be repeated. Okay. All right. Number 2, the n objects are distinct. Again, they're different, but this time repetition is not allowed. So once we use the number, this would be like I've got 5 people, and I want to figure out how many groups of 3 I could do. Okay. Once I've used Holly, I can't use her again. So she cannot be repeated. Okay, that's the thing. So I've got 5 choices for the first one. Okay, I've got, now I'm down to 4 because Holly's out. Now I've got Emma. Emma's out. So now I'm down to 3 people to choose from. So that's repetition is not allowed. Okay. And by the way, R in this process you're picking 3 from 5. It would never make sense to pick 5 from 3. Just think about that one. Okay. And then 3 is probably the weirdest. The end objects are not distinct, and we use all of them in the arrangement. So this is going to be like, let's look at the word Mississippi. M-I-S-S-I-S-S-I-P-P-I, right? Okay. How many letters is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 letters. A PPI. Yes, there is. Okay, so there's 11. Thank you. All right. Okay. There's 11 letters, but there's a lot of reruns. Okay. Not distinct. There's the same. So we're going to do something with, we got 1 M. We got, how many I's? 1, 2, 3, 4 I's. We got 2, 4 S's, and we got 2 P's. Okay? And we'll come back to that. But those are the 3 different kinds we have. All right? No. We haven't done anything. We're just looking at it. Okay. So here we are back to a code. In the FBI assigned 4-letter codes, the FBI assigned 4-letter codes to various operations, such as Operation ERRT. Notice that repetition of letters is allowed. How many codes are possible? Okay. Well, 4 letters. Here we go again. Seems like we did this last section. All right. How many letters do we have to choose from? 26. We can repeat them. 26, 26, 26. Or 26 to what power? 4, which is what number? Okay. 4, 5, 6, 9. Okay. That is the number of 4 codes available. Don't forget what you're doing. Number of 4 codes using letters. Okay, that's what that is. All right, here is a little shortcut if you like it. And again, this is a permutation, which is just a number of things that we're finding here, distinct objects with repetition. The number of ordered arrangements of R objects chosen from N objects, which is all permutations, R objects chosen from N objects, okay, in which the N objects are distinct, different, and repetition is allowed is N to the R. N is the 26, R is 4. Okay, so this is the. Yes, we did. We did it this way in 13.1. This is a little shortcut. Okay. Permutation, just a fancy word. It's just a number of items, number of groups. I don't know what it even how you define it. Okay. Let's look at this. This is another distinct without repetition this time, though. So this would be case number 2. Suppose the FBI for their codes decided they did not want any letters repeated in the 4-letter codes. How many different 4-letter codes are there without repetition? Sorry. So we go to 26. Now that letter is out. So then we go to 25, 24, 23. Okay? So 26 times 25 times 24 times 23 gets us down to 358,800. So considerably less than if you allow those numbers to be used. Okay? All right. How many ways can 6 people be lined up? Go ahead. I'll give you a minute. Once they're lined up, they're not available anymore down the road. get, Megan Cook? You got it 720. Very good. I assume you did 6 times 5 times 4 times 3 times 2 times 1. Okay. Very good. All right. So there's 720 different ways that you can line up 6 people. Okay, that's a lot. Okay. All right. Let's talk about theory. Permutations are objects chosen from distinct objects without repetition. We have a formula. Okay, this P stands for permutation. N and R are the usual. N objects taken R at a time. Okay. Now let's check out the last example here. All right. 6 people, let's see. Let's just practice the theory real quick. How about? Then we'll go back. All right. Now you have a couple of options that you can use. First of all, you have to be able to see this can be written like this, can be written like this. Okay? It just varies depending on, I guess, who's writing it. Okay? This, to me, is the most common, but remember my experience is pretty shallow. Okay? But they all mean the same thing, and they work with this. So let's say we want to do the permutation of, we're going to use the formula, 6 things, 2 at a time. Okay? So if we use the formula, this is N. N is always the first number and the bigger number. 2 is the R, the second number, and the smaller. Or it can be the same. Okay. So N is 6, so 6 factorial. I'm just using this formula here. 6 minus 2 is 4 factorial. So this is 6 factorial over 4 factorial. Okay? Now, this is like that example that we just did on the very first page. I know once I get to 4, my 4 is all going to cancel with this. So I'm not going to write it out. I'm going to think ahead, and I should get 30 for my combination, for my permutation. All right. Let me show you here in the math category. In the probability, again, see the permutation? Okay, so again, you got to think ahead. You got to say, all right, I'm going to do 6. Then I'm going to do permutation. So I got to go math, permutation over here in probability number 2 this time. Okay, and we're taking 2 at a time. Okay. 6 minus 2. 6 minus 2. I'm doing the formula.
I know, what you're doing an example.
I just made it up. Just made one up. Okay. All right. So now my calculator at home did not look like this pre-permutation. Does yours? It looked like it did 6. I just showed you how to do it.
No, I was doing an example.
It's 30, which is what we got. Okay. 6. Probability. Math. Over here, probability. Number 2 is permutation. Except I didn't get number 2. I got number 2. Okay. And then taking 2 at a time. There we go, 30. Okay? Now, that's the calculator notation. It will also, but they all mean the same thing. Okay. So, let's talk about this example. All right. 6 factorial over, 6 minus 4 factorial. There you go. All right, what's 6 times 4? 2. So 6 factorial over 2 factorial. All right, 6, 5, 4, 3, 2, 1. 2, 1. Cancel. All right, now you can throw that in your calculator. Now, I think it's kind of a pain, so let me just show you a little trick to find that permutation. There's a lot of, so here's what I like to do. I just like to say, okay, let me just go find one here. But, and then just switch up the 6 and the 2. The 6 is good. I'm going to switch up my 2 to 4. And that should be 360, which is, if I multiply 30 times 12, that's what I'm going to get, right?
Yeah, I can't get that notation.
You're not going to get that notation.
It's just that.
Try it again now. I don't know what you were making wrong. But
No,
no, it's not going to look like that.
Can you unlock this?
I'll send it to her. I know, but it still works the same, right? It's just the most updated thing is probably this one. You have the most updated? Yeah, mine. All right, you Faye, there you go. Welcome. Okay. All right, did you try 7-2? Okay, honestly, you can almost do them as quick as, I know this is going to be 7 times 6 without putting them in your calculator. It's up to you. Yes. Yeah. 40, and then 40 minus 4 is 36. So all I'm going to have left, there's 36 on down is going to cancel, so I'm going to have 40 times 39 times 38 times 37. Okay, so you could do that too. You could plug in the formula. Let's clear it out. Let's do it all. All right. 40, math, probability, number 2, permutation, 4 at a time. Okay. All right. I could also do 40, the fraction with the formula. 40 factorial. You need to know the formula. 4 over 36, math factorial, number 4. All right, should get the same answer. And one more choice is just by hand, except for the multiplication gets pretty ugly. There's your same answer. So you can do it any number of ways. I wouldn't rely totally, first of all, I wouldn't rely totally on this notation here. I would know how to apply it more than just one way. So sometimes that gets weird anyway. All right, any questions on permutations? Okay, that is the formula for, again, let me go back to the original 3. Where are they? Here we go. That is this one. ENR. Repetition is not allowed. Okay? Now, it's okay to go back to this as well. It's the same idea. Okay? Because sometimes you can't think of how many of them I taken out of time deal. All right. Any questions? Okay, let's go on and do combinations. Okay, because there's a difference between combinations and permutations. A combination is an arrangement without regard to order. Okay, so if I'm doing a group, and I want Holly, you, Faye, and Megan in this group, it doesn't matter how I list them. Okay, however, if I'm choosing first, second, and third place, order matters, right? Because if I say Holly first, that's first place. You, Faye, second, that's second place. etc. So that's what it means without regards to order. Does order matter? Okay? And it matters if it's different. Okay? All right. If our object selected from N, again, we have distinct objects, different objects without repetition. Repetition. Yeah. Okay. R is always less than or equal to N. It can be the same. All right. The notation C as opposed to P, N, comma, R represents the number of combinations. I'm sure you saw that when you were up here looking into probability. See the CR is right there. Okay, right underneath the P. Okay. So here's the criteria for combinations. N objects are distinct. Once an object is used, it can't be used again. Order is not important. There's the formula. Notice it's almost the same as the P, except we have this extra piece here that gets divided. So which is going to be more, permutations or combinations? Permutations always going to be more, because you're dividing by a bigger amount in the combination. Okay. All right, list all the combinations, now they're really being obvious here, of the 4 colors, red, green, yellow, and blue, taken 3 at a time. So you got 4 colors, combination taken 3 at a time. It's real obvious. So we'll use the formula. 4 factorial over 4 minus 3 factorial, and then 3 factorial. Okay? Remember, this is 1 factorial. 1 factorial is 1 in the first definition. 4, 3, 2, 1, 3, 2, 1, 3 factorial does cancel. We should have 4 combinations. Okay? It doesn't matter if I just pick red, green, and yellow. That is the same group as yellow, red, and green. We're not counting that. See, a permutation, we count that as 2 different groups. A combination does not, because it's the same 3 things. Okay, that's the difference. All right, go ahead and find those 4 examples. Kind of switch it up. Use your formula. Use it by hand. And use the thing in the calculator if you want. I'm going to do them all by hand. So.
Would 2 exclamation times 2 exclamation equal 4 exclamation?
No. Well, because 4 exclamation, 4 factorial is 4 times 3 times 2 times 1, Megan. 2 factorial is 2 times 1. There'd be no way a 3 would enter up in there. I'm done whenever you're done. What? Five factorial. I did it by hand. What'd you do? Are you doing it by hand?
She doesn't see that you crossed out.
5, 4, 3, 2, 1 is right here. This is 3 factorial, 3, 2, 1. This is 2 factorial, 2, 1. 2 times, these cancel. 2 and 3. 3 cancels with 3. 2 cancels into 4 is 2. 2 times 5 is 10. Well, I mean, you got to do what you got to do to get that down to whatever you want it to get down to. It's not just arithmetic at that point. Okay, any other questions? When your N and your R are the same, you're always going to get that. Okay, because think about it. I'm taking 5 objects 5 at a time. There's only one combination that I can have. I got them, I'm done. Because if it doesn't matter what the order is, then that's it. So it does make sense if you think about what you're doing. Okay, ready to move on? All right, let's talk about committees. I like committees because committees starts with C and it's definitely a combination. So it's easy to remember. Okay, how many different committees? 4 people can be taken from a pool of 8. So what's my notation here? How many people taken blank at a time? 8 people taken 4 at a time. Okay? So again, do what you got to do to evaluate that. Nope. You just do what you got to do. I got 7. Okay. Yeah, if you're looking to find that, you gotta think ahead. You gotta, unless you're gonna go up and grab a C. I haven't done one yet, so let's do. I gotta do 8. Then I gotta do probability, a combination, number 3, and taking 4 at a time. Here's my 7. I wouldn't count on just this piece, is what I said, because you wouldn't be able to do some of the abstract ones. I would know the formula. How many ways can a committee consisting of 3 boys and 2 girls be found if 7 girls and 10 girls are eligible to serve on the committee? 7 boys and 10 girls. What do I think? Okay, anyways. Okay, so this one's got a little twist, of course. Okay, it is a committee. All right. So I can't put the boys and the girls together because I'm taking from the, I'm going to take 3 boys from how many? 7. And this is the number of boys. And then I'm taking 2 girls from 10. Okay? Let's see. All right. So figure both of those things out, and then we'll figure out what we're going to do with 2 of them. Okay. Get 35 and 45? Anybody not? Get 35 and 45. Okay. So I just totally plug those into the calculator. Easy route that time. Okay, now, what do you think we should do with 35 and 45? What? Multiply them? What? Who thinks we should add them? doesn't have a clue.
Should we do? Should
Thank you, Megan.
We could be honest.
That's what I like, honesty. Yes?
Should we multiply like 35 times 34? Because there's 3 boys, or am I doing split?
No, you don't need to go to that much detail. You've already found out that there's 35 possibilities for the way you can pick out boys, the groups of boys. You've already figured out there's 45 possibilities for the way you pick out girls, for the groups of girls.
Who would you do that?
No, we're not going to put that. We are going to multiply them, okay? The multiplication goes back to the principle from 13.1. Because it says, wait, here are my options for this. Here are my options for this. It's like I have my 4 pairs of shoes. I have my 2 outfits. I got 8 combinations of just those 2 things. 4 times 2. Okay? So we are indeed, so that was a good instinct, Miss Yufei, going to multiply them. Does that make sense? You're going back to that multiplication counting principle where you get the number of combinations. And I say combinations kind of freely when I'm talking about permutation and combination. So these are the number of groups that you could have with that criteria. 7 boys, 3 of them taken, 10 girls eligible, 2 of them taken in the groups. Or 7.
How did you know that it was a combination?
Because it's me, yeah. And it doesn't matter if I'm going to pick what order I pick out. It doesn't matter. Okay? Order doesn't matter. And no repetition. Okay? All right. Any other questions? All right, let's talk about one more thing. That was the 3rd item. So just going back, revisiting here what we've got so far. We've done number 1, which was really, we did it counting wise, or we did something to the, whatever power. So those are what we did also in 13.1. This is the permutation without repetition, which is combination right here. Could also be okay, and then this is the last one that we're going to talk about. Now the book does a terrible job of grouping. Here's these, then here's these, and then here's these. So pay attention when you're doing the problems that I've assigned that you pay attention to. Why is that one? Because I know that's how it works out because I'm looking at the answer, but make it bigger than that. Make sure you understand why you're doing that one as opposed to the different one. Okay, permutations involving n objects that are not distinct. This is the Mississippi. We've got a lot of repeated things here. Okay, the number of permutations of n objects of which n1 are one kind, and sub 2 are another, and sub 3 so forth. So, okay, so how many different 11-letter words? Let's go back to Mississippi. M-I-S-S-I-S-S-I-P-P-I. All right, we said there was 11 letters, so we're going to do 11 factorial on the top. That's the total number of objects that I have. Now, the repeated things go on the bottom, and all of them together should equal 11. Okay, now some of them are kind of be like superfluous because 1 factorial, what is that? It's 1, but we'll put it there just so we know we're going to add up to 11. So I got 1m. I'm going to just write it n down here. How many i's do I have? 1, 2, 3, 4? That's my I. Okay. How many s's do I have? Another 4 factorial for my s's. These are all multiplied. And 2 p's, right? Did I miss anything? So 8, 9, 10, 11. This number should add up to this number. Okay? So go ahead and evaluate however you want to do that. It's going to be kind of a pain. I'll do it by hand just because I am crazy like that. That 4 is going to cancel there. Let's see what we got here. 6, 6, 8. Did you get that answer? I'm double checking mine. When you start canceling all over the where, sometimes you lose things, so be careful about that. That's one disadvantage of doing it by hand, is that you do sometimes lose some factors. Did y'all get what I got? Yes, thank you for answering. Hit the rand again, dang it.
So the ones that are one isolation point, you can kind of just ignore it.
Yes, because it's just one. Yeah, you'll figure out, good question, Emma. You'll figure out a lot of things that you're like, okay, I'm not going to really write that one down. There's your, okay. You can't use the formula, either the combination or permutation, because it's not a straight up permutation or combination. This one is got its own little thing. Okay, so have you done the 11 letter words, real or imaginary? So there's 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, can be formed in the word mathematics. All right, so what's on the bottom here? 2 factorial, 2 factorial, 2 factorial, and then the rest of them are ones. 2, 4, 6, 7, 8, 9, 10, 11. That's annoying, but anyway, just to be consistent, you don't have to do that. Just remember that this should add up to be 11. So I got my M's here. I got my A's here. And I got my T's, and that's the only thing that repeats. Okay, so when you're plugging that in, let's go back, because I already got 11 factorial already set up. I can get rid of my 4 factorial, make it 2, get rid of my other 4 factorial, delete, and I'm good. That's a lot of words. Or some of them aren't real words, most of them aren't really words. Yes, just I was so eager to. I should change both my 4 and my 2. All right. Whoa, 2. Thank you. And 2. Wow. I didn't save myself any work, did I? Okay. How's that? Better? 4,989,600. Okay. All right. So that one's easy to spot. Okay. You do have to remember the formula. All right. Go ahead and do these last 2.